Hi everyone, and welcome to the Avid CNC live stream. Thanks for joining us today, and we have a very special guest, Robert Cowan. Thank you for being here with us today.
Of course. Thank you for having
It's
me.
awesome. I love, the first thing with this view. This is amazing. Your shop is beautiful, and I realize it's out of your garage, but like the way you've dialed it in, it looks really wonderful, like a dream.
Well, thank you. I'm still moving stuff around with COVID going on. You can't see I have this massive workbench island here in the middle. It's I don't know, 15 feet by 6 feet. This huge island in the middle, and I'm still kind of rearranging things and figuring out how I want it, but that's how it goes.
I think that's kind of the
Yeah,
home maker space. I have all these different sections in my house. Basically, the whole house is a maker space now. The deck, the office, the living room is the photography studio. So there's a lot going on. Thank you everyone for being here. Izzy, good to see you. Olivier, Paul, Dave, everyone, thank you for being here. Let us know where you're tuning in from. And if you have any questions throughout, please feel free to drop that in the chat or in the comments.
yeah, no, we welcome additional questions. We're going to be reviewing a number of different topics with Robert here, and yeah, so please, if you have any questions, let us know. Also, if there's any audio issues at any point, please put your hand up, and we'll try to resolve those as quickly as possible.
Yeah, awesome. Well, let's just go ahead and jump into it. So, uh, you are very well known on, you have a YouTube channel. So first of all, let's get some background for those who might not be familiar with your fabulous channel. I'm just gonna pull it up here so that everyone can see. Uh, okay. And you primarily focus on making combat robots. I know that you make lots of other, uh, a maker, tinker, you have lots of different, we all wear lots of hats these days, but uh, I think you're really well known for combat robots. Is that right?
Correct. Yeah, I started out, man, I started out a long time ago. Most people don't know this, but my first project ever when I got back into making was building audio amplifiers. So I kind of have a big audio background. I actually worked in the audiophile community for a really long time, and I was building my own audio amplifiers and stuff like that. And that got me into CNC. So then I started building my own CNC machines, doing some mill conversions, things like that. And then I worked with someone that was building combat robots, and that was it. I just started building combat robots. And once you start doing that, you kind of get a little obsessed with it. So be warned. But yeah, then I just kind of went from there, and yeah, the rest is history.
Yeah, no turning back. Awesome. So I know that you might have a robot near you. Can we see?
Yeah, I've got like three here on the table. So with combat robots, there's different weight classes, much like boxing or something like that. And these are 3 pound combat robots. So this is Psychotic Break version 2, and it uses this spinning weapon on the front. It's got a carbon fiber chassis with, I think this is glass filled nylon for the body. And then this is version 1, which was actually one of my first projects made on my Avid CNC router. All of these frame parts were made on the router. And then I have a very non-traditional combat robot. Most people wouldn't think of this as a combat robot, but this is Lolo Man. It's about 14 millimeters thick, and it's basically meant to just really frustrate people because it's so low. And this is made out of a single billet of aluminum, and it's a 12-wheel drive bot, and it's basically just really difficult to get to. So it's just supposed to frustrate the other opponent.
Um,
So yeah, those are just some of my small
yeah.
ones.
Well, so while we're still on the topic of Lolo Man, I just have to show everyone my favorite clip. After, I used to watch Battlebots as a kid, but this has really gotten me back into it since getting to connect with you and watch all the things that you do. So this is just, I think, one of the most fun moments. And this is Lolo Man battling. I don't know what the name of this robot is, but it just does this
Rickety
absolute
crick.
wonderful rebound where none of the other robots can like pick up or really damage Lily Man because he's just like, running around really flat, low to the ground, and this robot's just saw blade just rebounds off the wall and into the, I don't know, the pit or whatever. It's wonderful. Just like
Yeah.
absolute joy. I just rewatched this, I don't know, this is maybe almost a year ago, but it was just watched it 10 times in a row.
Yeah, and that fight was really interesting because Rickety Cricket, the other bot, is a gyro spinner, and so it only moves by using the gyroscopic forces that are generated by that weapon. And what's really interesting about it is I usually watch all the fights and kind of get an idea of how these bots are working. And the interesting thing about a gyrobot is when you have that much gyroscopic force, it's very unstable. And so the clip that you played was simply if you tilt the bot, it will become unstable. So I drove underneath of it and then backed up, which caused it to nosedive, caught the floor, and then went in the pit. So, sometimes it's a lot about strategy, is just kind of figuring out the weakness of the other robots. And with an unstable robot, you just kind of want to get underneath of it, push it a little bit, give it a little bit of nudge. And that's pretty much all that Lolo Man is about, is just kind of using the other bot's weaknesses against them.
I guess it's an interesting thing because it's kind of like rock, paper, scissors, where each robot has its strengths and its weaknesses, and they're not all. You're not going to have one robot that's ideal against every other robot. It's just kind of, you hope you're in the tournament like going to be paired against your ideal candidate, or component.
Yeah. Yeah, it's exactly that. It's you just gotta kind of figure everything out. I always say that combat robots is quite simply you're generating kinetic energy, you're storing kinetic energy, and then you're transferring it. So this right here has no stored kinetic energy. But when I start to spin it, this weapon then stores that kinetic energy, and then all I have to do is take that kinetic energy and transfer it into the opponent. So it's really just simply about energy transfer. And with a bot like this, it's the same concept. It's just that I'm not generating any kinetic energy. I just have to figure out a way to transfer their kinetic energy back into them or into some other aspect. So yeah, it's a really cool physics experiment on just simple energy transfer.
That, and it's a really frustrating opponent because they don't know how to pick on you. And just like other things, there's a certain psychological element into these fights, right? There's a risk reward, how much of the bot can you sacrifice in order to win? And I feel like you bring in a lot of psychological strategy into the arena in that sense.
Oh yeah, for sure. One of the classic strategies is with a bot like this, the wheels are exposed, and a lot of people will say, oh, the wheels are going to be the first thing that people go for. But the length of this bot, it can flip around very quickly. So if you go for the wheels, you can flip around very quickly to get there. And everything has a reason. This weapon is painted black because when this spins really fast, the weapon just goes away and you can't see it. So when this is spinning, you don't really know that this is actually the arc of danger. You really can't be anywhere in there. So if someone's going for the wheels, all it takes is just a couple of degrees and you're going to get hit.
Yeah. Well, those are some of your lightweight robots. Can you maybe give us, for a sense of scale, maybe a part of one of your heavyweights?
Yeah. Yeah, so these are 3-pounders, and 3-pounders are great because they're kind of a good amateur weight class. There's 1 pound and 3 pound, and without COVID, there would most likely be an event near you somewhere in the U.S., but we're kind of limited right now with that. So this is the insect class. They go up to the big ones. To give you a sense of scale, this is a wheel from one of my big ones. It's a 250-pound bot. And this wheel's about 15 pounds. And I think I've got the weapon. This is the weapon for a 250-pounder. this is over 50 pounds of solid tool steel, and this will spin. This is in Copperhead, which competed last season of Battlebots. This 50-pound slug of steel will spin at about 10,000 RPM. And at max speed, this stores about 25 kilojoules worth of energy, so 25,000 joules. And it's roughly equivalent to, I don't know, a couple dozen 12-gauge shotguns right at the muzzle. That's about the power that this has on the tooth when it hits. It's an extreme amount of power.
Yeah, no, that's a lot of stored energy there at 10,000 RPM.
Yeah, we take about 20 horsepower to get it up to speed. It takes the old version, hint, hint, the old version takes about 7 to 9 seconds to get up to speed. The new version, we've cut that down to about 4 seconds. So we're getting from a standstill up to about 25,000 joules worth of energy in about 4 seconds. And it takes about 300 amps worth of current dumping into the motor to get up to there. So it's just, silly numbers.
Yeah, and that has to make a very intimidating just sound. I bet you just watching it spin, not even engage with anything, has an intimidation level.
Yeah, there's I do have a video on my YouTube channel of the sound of Copperhead. So when this weapon's asymmetric, right? It has a tooth that kind of sticks out and then it's balanced on the back end. And when it comes around, it basically chops air against the frame. And the video is well worth watching. Go check it out. But this goes at about 120 decibels when it's on full blast. And it kind of has a nice resonance in your chest. And it's very, very loud, and it kind of gives you this primal sense that you need to leave.
Yeah.
And it's very scary.
Well, you told us about the arena that they battle in. We see it makes you very safe on the outside.
Yep. Yeah, it's the arena. There's obviously different weight classes. Even in the small weight class, the arenas are all Lexan, which is bulletproof glass. They almost always have a steel floor to them. And the battle box, which is the Battlebots arena, I think it's about 20 feet tall. So when you're watching it on TV and you see these bots fly up in the air, they're flying upwards of 14, 15 feet in the air and landing back down. And it's, 250 pounds. Like, I have an issue just holding the drum up in the air. So these bots will fly 15 feet in the air, fall down the ground, and I think they have like 3 or 4 layers of bulletproof glass. You could go up to the glass with an assault rifle and it wouldn't do anything, but these bots have actually cracked the glass before.
Yeah.
So it's scary. And if you watch last season, there's one instance where I'm driving and I actually knock a bot directly into the glass directly in front of me. So I'm less than a foot away from one of these things. And it's a very fun experience to experience once in your life, having 250 pounds launched at you.
I hope they caught that moment where you're just like shocked, but okay.
Yeah. And you just got to keep driving, keep doing your thing. And the adrenaline rush after, it's a 3-minute match. And after that 3-minute match is up, you're just spent. Everything feels kind of noodly and gummy. And you don't even remember what the match was because there's literally death machines in there inches away from you. And you're just hoping that glass holds.
Yeah. Well, I know the Battlebot season this year was delayed, but I think we've ironed out some timeline on the 2020 season of Battlebots, right?
Correct. So yeah, very pleased to announce that Battlebots is coming back. Filming is going to be out in LA from October 2nd to the 15th. So we're going to be doing all the filming then. I don't have a word on when it's going to air on Discovery Channel, but hopefully sometime later this year, we're going to see it start getting advertised on Discovery Channel. But I think they usually have about a 2-month turnaround, so we could definitely see it maybe by December, somewhere around there.
Fantastic. Yeah, no, I've been a big fan of Battlebots, the big weight class for many seasons, and look forward to seeing you guys compete.
Yeah, thank you. It's a great time. It's come a long way. If anyone remembers it back from the Comedy Central days, you just didn't have the technology back then. New technology in lithium batteries, new materials like metal like this didn't exist back then. I'm just saying it's tool steel, but this is a special type of tool steel. Metallurgy has come a long way. We know a lot more about how to keep something like this hard but not brittle. So this can take large impacts and not just explode. So yeah, the material science has come a long way in battery technology, and also the introduction of different types of motors that let us get 20, 30 horsepower in this little machine. It's come a long way.
Yeah, that's awesome. It's cool to see and get to hear about the theory and why you're so drawn to it, and kind of get to even see the iterations of the process, uh, how they kind of evolve.
Hmm.
Yeah. Well, I'm really excited, and you reached out to us, and you asked if we could help you build a couple components for Copperhead this year, and our machine shop had some capacity at the moment, and so I'm excited to see how Copperhead performs, and how far along the tournament you guys can reach. So another big fan here. So thinking about these different bots and systems, Robert, I think about you kind of as a renaissance maker, in that sense that you're doing all sorts of different materials and types of projects. Where do you normally do your research and kind of learn about some of these different or new ventures?
Yeah, that's a good question. I really don't have a formal education in any of this stuff. I'm the product of a need, and then I just go out and try and find the information that I need. And my background is actually psychology. So my degree is a psychology degree from University of Colorado. I don't have any formal training in engineering, but I've always kind of sought out a some kind of project or something that I want to make, and I'm like, I could make that, and then I just go on YouTube and search videos. So my channel is really a product of that. When I learn something, I want to give people back the same knowledge in the same way that I learned it. I don't want to do a 5-hour lecture on physics, but I can explain what MOI is, moments of inertia, in like 5 minutes, and kind of give you an idea that, okay, the further away from the center of rotation the mass is, the more energy it can store. So, there's practical knowledge, and then there's fundamental knowledge, and sometimes they interact. And sometimes it's nice just to learn the basics that you need for the hobby. If you look at a wood turner and they're using a lathe, you need to know surface feet per minute and RPM, and knowing the relationship between those. I think every hobby has that proprietary bucket of knowledge that if you know these things, you're going to be successful. And I think YouTube is a fantastic resource because you can find out this knowledge very focused on the hobby and the project
Yeah.
you're going after.
That is something we talk about all the time, and that's why we try to offer all of our educational content on YouTube, because it's really the great equalizer. Everyone has access to it, and part of our mission is accessibility, and the fact that now the format of education is changing and evolving. And while there are classes online that you can pay for, there's so much content and educational free resources, whether it's someone like yourself who's learned this practical knowledge and can break it down in an accessible way, rather than being, here's the physics textbook, where that doesn't feel as approachable when you're just learning on your own. So I'm very excited to see how education changes based on this, access to information. And that's really, so we've already kind of got to a place where it's infinitely changed the way we learn.
Well, and I guess,
Uh,
Robert, knowing that there's an infinite amount of different things we can learn, how do you transition from going from research into actually producing or making a first attempt at something? Like, what does that transition look like? Because I sometimes feel like I can research things to death, and yeah, what does that look like normally?
Yeah, that's a very fair question. I prototype a lot. Part of what I do is just kind of trial and error. And one of the reasons why I landed on building combat robots is they give you that feedback loop, right? If I build this, it looks cool, right? And it drives around and this thing spins, but I don't really have that feedback loop of is it doing the thing it's supposed to do until I put it down in the arena and realize, oh, okay, that was the wrong decision. That didn't work out. And for me, that's kind of just why I'm doing what I'm doing with combat robots, because it gives you that very quick iteration. If a motor is going to fail on you, or if the gearbox is undersized or whatever, you're going to know that in like a minute, really quickly. And then you go back and you realize, okay, I'm going to harden these gears and I'm going to do this and I'm going to do that. And you make all these decisions very quickly based on need. And furniture, like if you build a table and I set my glass down and it holds the glass, that's it. It's a table. It functions as a table if it's, roughly level and it's the size that you need. And I'm not saying anything against people that do woodworking, but it's tough to know when you've reached the end of that research. Because then you always kind of have to push yourself and like, okay, now I want to try, like a resin waterfall table. I want to try this or I want to try that. With combat robots, it kind of spoon feeds that to you. That it's like, no, this failed. You need to fix that. So, to answer your question kind of more directly, you just kind of have to make a best guess. And the more experience you get, you realize like, okay, I think this is going to work out. And sometimes you're wrong and sometimes you're right. And you just have to, also when you research something, sometimes you just want to give up and just be like, okay, I just want to make the thing at this point. And I've definitely gotten to that point to where I just need to get in the shop and just start making something.
Yeah, and it's as you described that, Robert, I actually am hearing you talking about how I approach feeds and speeds and some of my CAM techniques. It's a guess and observe, and then understand your observations. Right, the big, I feel like, leap when people are learning CNC machines that they make is the power of that observation, and then making a change based on that observation. And I feel like as a machinist, once you can define that observation as something you're aware of, that's when it starts becoming really fun, because now there's a feedback loop and you can iterate and you can really get the perfect chips off of the machine, the best cut quality, finish, speed, whatever your goal is. I feel like as you describe that, that's my tools, toolpath feeds and speeds approach.
Yeah, that's a perfect example because you guys know that I have the 2 videos on facing. I got a Datron end mill and I did one video on facing, and I'll admit I rushed it a little bit. I kind of was just like, hey, I faced the thing off, it's level, it's flat, but it wasn't optimal feeds and speeds. And I came back with a second video and like, okay, let's try and get a better surface finish. Let's get more material removal. Let's kind of do this again and look at it a little bit more. And you can kind of keep tweaking and keep refining. And sometimes when you're making something, you just need it done, right? It's just like, okay, I need this done today. I'm going to use these really safe feeds and speeds. I know they work and I know I'm going to get it done. I might get a little bit of chatter, but I'm just going to get it done. But then other times, maybe your goal, for something like this, I really wanted this to be pretty. The part of the aspect of this bot is that it was supposed to be beautiful. This is a combat robot that's meant to get destroyed. And I kind of wanted to add that psychological element of someone that felt a little bad hitting it, or it's a little bit of show-off factor, right? It's like, why would he polish this robot knowing that it's going to get scratched in 5 minutes? It's kind of like a little bit of an insult, right? You put something in there that's so pretty that they're just like, you kind of, make them a little mad by it.
Yeah.
And for this project, it needed to look nice as well as be accurate. So, I spent a little bit more time with the feed speeds on that.
So I guess knowing that observation is kind of one of the things we're trying to do, machining aluminum specifically, what is going through your mind when you're trying to observe your chips that it's creating? Do you have any couple of specific observations that you're looking for a great toolpath to show you?
Yeah, I am not a machinist. Everyone that's watching, I'm not a machinist. The biggest thing that I look for when I'm doing aluminum are the chips going away? because you don't want to recut chips. So that's the first thing I look at, is when it makes a pass, are there no chips afterwards? Because if you get a lot of chip buildup, if you're doing like a pocket or a bore of some sort and it's full of chips, you're going to have a bad time. You're going to get chip weld, whatever. And then I think listening to it, that's just the biggest thing, is experience, right? If you're getting that screeching, you're going too slow. If you're getting chattering, maybe you're taking too big of a cut, and just listening to that cut. And when I'm cutting, I'll always have my earmuffs on, my hearing protection in, but I never have music playing and I never have anything going on in the background. And the earmuffs are actually really good at blocking a lot of the noise. So then you can kind of hear the cutter a little bit more, and you can hear, is it screeching? Is it grinding? Is it rubbing? And sometimes you just got to trust your instincts, and then sometimes you just got to be like, you know what? It went through that whole pass just fine. It didn't sound amazing, but it's cutting. The chips look good, and just kind of let it be. So it really depends. I know on one of these projects, the cut just didn't sound all that good, but it was just because it was not a rigid work holding. I just couldn't hold it as rigidly as I wanted. And you know what? It's cutting. I'll come back in the finished pass and clean it up. Some passes are about material removal, and some are about getting it to the tolerances you need. And I think that's the biggest thing I've learned over the years, is if you're just trying to get the material out of there, as long as the cut is working and you're making good chips, leave it.
Yeah, no, that's a great point. Understand your goal, right?
Mm-hmm.
And sometimes the goal is very aesthetic, and sometimes it's, I need to finish this in an hour. And then how do you leverage that tool to achieve that goal? And I think you're exactly right. I feel like understanding the problem at hand is a great way to leverage these machines to achieve those goals.
Yeah, and it's with the Avid CNC router, people always ask me, I get a lot of questions from YouTube and elsewhere. They're like, how accurate is it? How precise is it? And it's like, well, it depends on what you're trying to do. For some of the pieces in this bot, these don't need to be, plus or minus 5/1000ths of an inch, whatever. It's not that critical. But there's bearing holes in here, and the top and the bottom need to be very well aligned to each other. So those were roughed out. And then when everything is roughed out, then I go back through and I just kind of work up to it, maybe 1/1000th at a time. And yeah, those are the perfect bearing fits, where the bearing just slips right in. It aligns axially through the whole bot, which is exactly what you want. And so sometimes, yeah, you're perfectly right. You just have to realize what you're trying to accomplish. The rest of it didn't need that much attention to the contours. But when it gets down to those bearing pockets, you got to pay a little bit more attention. So make sure you do a light cut, work up to it. And yeah, I've had no issues with bearing fit or getting things just right if you just kind of pay attention to it.
Yeah, and Sam, I know you've done this with a number of different projects that you've made, where you have kind of a scale of tolerances that you're trying to achieve based on, is this a joinery aspect or is this an outside edge?
Yeah, totally. Yeah, it's once again, I don't have that engineering background, but you definitely learn what's important and what's not important. And if something is really critically important, like the bore on the end of this weapon, you're going to pay different attention to it. You're not going to run the same adaptive path and then just come back through with a contour. You're going to click that stop to leave. You're going to add a little bit, then come back. And in my cam, I always have cleanup. All my cleanup passes are always those passes where I come in, one thou, check it. Okay, another thou stock to leave, check it. And you kind of work up to it.
And it definitely does depend on what you're trying to make. And you can work up to that tolerance. And it also kind of depends on, what you're trying to do. When I'm making pieces of furniture, my joinery for plywood is much, more generous than, for example, like your aluminum walnut inlay. I'll just pull this up here so folks can kind of see this. We have some really good questions here. If you don't mind, I'll read some. Chuck asks, do you have any recommendations for the most cost-effective way to get started in local competitions? What weight class? Are there available kits? And to kind of build a home practice arena?
Yeah, I'm Googling this right now. I have a video which I'm going to link. I found the link quickly. I'll put this in the comments. I approach education a little bit differently. That's a big question with a lot of different pieces. Like, okay, you're going to have to get a battery and a battery charger and these tools. I put together a video a little while back that's the Combat Robot Resource Guide. I feel it's better to kind of point people towards where can you find local competitions and where can you ask questions. And in that guide, I have a link of resources for getting started. There's a couple links in there for different companies that sell kits. So you can get a kit, go to a local competition. My biggest advice, if you do want to get into combat robots, is get involved in the community, because every single person in the combat robot community just wants to have a good fight. We just want to see stuff go smash and explode. So everyone is trying to help everyone else. And before, even on Battlebots, the TV show that, these things are $20,000 robots, right? Before a match, we're giving each other hints on, oh, if you do this, we want to see a good show. And so for combat robots, get involved in the community. There's Facebook groups, there's a bunch of forums, and then you can get the help and the resources you want to be successful and have a good time.
Awesome, thank you. Also, Glass Impressions, you're is inspired to make their own pneumatic blast gate, which was also a very cool project, I think, which kind of leads us to something we're really interested in touching on, which is how you've really customized your machine to fit your needs and making all these very specific projects to kind of dial that in. And I think that's something that, if you have the allotted time to do it, I totally understand if you're trying to hit the ground running with production. Sometimes it takes too much time to dial in all of those things, but if you do take the time, it helps with your production speed later on. If you have proper work holding set up, proper dust collection, you don't have to do as much sweeping after. There's a lot of things that can save you time later on if you take that time. So can you tell us about like those kinds of specific approaches you took to setting up your machine for your shop needs?
Yeah, that's a good question. Corey will remember this. You remember when I reached out to you in the very beginning. One of the reasons that I went with an Avid is I wanted that flexibility. At the time, I didn't know how I wanted to use it. And I'll be brutally honest, I just wanted a toy. I wanted something in that corner. And I kind of knew I wanted a CNC router. I have a Tormach over here. I wanted something bigger. I wanted to do bigger parts. And my first questions with Corey were, can I do aluminum? Can I do this? And, we talked about that. And I ended up going with Avid because I liked the idea of doing, a different bed. If anyone knows, I have kind of a hybrid bed. I've got aluminum T-slots up front with a Kurt vise. And then in the back, it's all MDF. It's kind of my CNC router mullet, I guess. And business in the front, party in the back.
Yeah.
And so I did that. And then I also have a fog buster on there. So the idea is that with the front third of the bed, it's all aluminum. And so I can use coolant. I can use stuff that would be otherwise detrimental with an MDF top. But then I get the flexibility of being able to screw something directly into the MDF. So I really liked that concept that I can configure the machine to kind of however I want. And now I have it as kind of an aluminum machine, but I also have the full surface if I want to do, something out of wood. And I did also add the pneumatic blast gate because I wanted that flexibility to, turn on and off the blast gate remotely from my dust collector. And being able to use Mach 4 to control that, it's just, I like flexibility. I like the ability to tweak it to my own style.
Yeah, we talked about it earlier, Robert, and I feel like, our architecture really allows for this machine evolution to meet your current goals and needs. And as you continue down your manufacturing rabbit holes and paths to meet your needs, I would not be surprised if we got to see this machine configured with different components for work holding or with different goals, and whether it's a machine extension or additional rotary function or just 3 more vices because you're trying to hold things, really big parts really firmly as you machine them. And we know the firmer we can hold our work, the better cut quality we'll have. And so I'm really looking forward to, this machine continuing to evolve to meet your needs.
Yeah, for sure. The biggest thing I'm going to talk to you about again, and I know the comments are going to blow up, an ATC. Having an automatic tool changer is one of the biggest next steps that I'm going to have, because coming from my Tormach, I am just spoiled with, you set up the job with this tool, this tool, this tool. And, I'm just kind of used to that. So being able to get the tool changer, I desperately want to throw my Heimer probe in there, and, just things like that. It's going to be an evolving machine for sure.
Yeah, no, and just to touch base on that, ATC is something we are also very excited about. But one of our company missions, making machines accessible, is really what is driving our current ATC engineering. And that is, ATC, there's a fair amount going on between your different tools and touch off positions and centering. And there's also a fair amount of, additional liability when you hit the green button. You have 4 or 5 different sequences that you're going to be running through that all have to be perfect in order for you to hit that button. And so what we're currently working on is really allowing an interface and a system that allows for people to be successful with hitting that green button in a way that there's a sequence that we go through, and it's really success driven. And so we are very much interested in ATC, and we are looking forward to bringing this opportunity, because it's really going to allow for these machines to increase in productivity and configurability.
Oh yeah, no, I'm looking forward to it. That.
Yeah. Cool. Well, your Blastgate video, you went really detailed into, not just the theory behind it, but the parts you used and how you got it configured. And so if anyone's interested in learning how to open or close the Blastgate through the software, Robert did a great video on that. You've also done some other videos on the fog buster and the different accessories you've added to the machine. I haven't seen you touch base on like vacuum work holding, and that's something that a lot of people ask us about. Do you have a current or future need for a vacuum work holding fixture, or do you prefer to use a vise or other work holding methods for the type of machining you've been doing?
Yeah, that is a good question. Yes, in terms of need, I think most of the projects I've done have or could benefit from vacuum work holding. I saw in the feed that you were showing the logo inlay project that I did just a few weeks back. That would have benefited from vacuum work holding. Lolo Man, being that this is just a large slab, that would have benefited from it. The reason I haven't done vacuum work holding yet is maybe I haven't done enough research, but a lot of them rely on the rubber gaskets. And with side loads, when machining aluminum, that's kind of tricky because you have a little bit of that rubberized feeling to it. And once you engage that workpiece from the side, you're going to get a little bit of flex. Winston Moy, who you guys know, he did a video on one of the work holding, I think, that Rockler offers. And yeah, he was finding that as soon as he hit one of those side loads, you could see a noticeable flex. There are work holding systems that will function, but I haven't found one that I really like for this. So, maybe you guys can look for some options. I think the other big thing too is the vacuum compressor needs, right? There's a couple different types of vacuum pumps out there. You have the rotary vane type, and then you have the diaphragm type, and there's kind of pros and cons to each. And it's one of those things that's tough to play with, because if you're doing it right, you could easily be in $500 or $1,000 for a good pump. And then you have this other thing running along with the spindle, along with the dust collector and everything else. So that's kind of why I haven't gone down that road. If there was a nice, clean, simple solution, I would definitely be interested. But for right now, I'm just using the, double stick painter's tape. Painter's tape and not hot glue, but super glue is a really good alternative to it, but it definitely has its cons because you really can't flip parts easily or index parts. So
Yeah, the efficiency of one after the other also is kind of lost when you're having to apply glue to everyone. And
Yeah.
I totally agree with you. I think vacuum can sometimes feel like it's a great universal solution for work holding, but then the actual implementation of it, we run into some issues. But I do feel like it as a potentially as a secondary or in addition to type of work holding, just like double stick tape to prevent material from lifting in the middle, but also using clamps or screws on the outside of that material to really hold it in place. And so having that secondary function of work holding with vacuum, I feel like there's some very approachable pumps and systems that then you can leverage in addition to clamps or in addition to another work holding method where you can maybe prevent the use of tabs specifically, right? Having a vacuum set up just so you don't have to deal with tabs at the very end could be a function that a small vacuum system I feel would show value for.
Yeah, for sure. And I mean, I'm sure you guys are aware of what Pearson Workholding. They have a really nice Venturi thing that you just throw some compressed air into it and then it creates a vacuum. And that looks really nice. It's very spendy, but that does actually look like a really good solution. I'm always trying to think of how to consolidate things. So it's like, okay, if I already have, you know, an air compressor, can I leverage that? But yeah, I would love to get a vacuum table at some point. I'm sure I could figure out some way to use it because yeah, most of the stuff I'm doing, you want to contour all around the outside and then do your pockets on the inside. And you know, vacuum is really just the best way to do that.
Yeah. Well, to throw you a little curveball here, you were kind of self-taught CNC, and today's CNC market is very different than when you first started. You know, we have tools like the Shaper Origin, and our systems are a good example of a kit-based CNC. There's you know other entry-level CNC machines that are either kit or pre-built. I guess if you were gonna give someone advice for beginning, middle, end, or a way to kind of dive into CNC manufacturing, what would you tell people today?
Oh man, what do you want to make? I, I have this video idea that I haven't made yet, but it's on my like list of video ideas, and it's outsourcing versus making. And CNC it's expensive, it's complicated. You guys can like plug your ears if you want, but you know sometimes making it yourself isn't always the right way to go. And on one side, having a CNC router and a CNC mill has allowed me to realize how to outsource stuff better. And I know that sounds really weird, but when you know how to make it on your own, you know how to design the part so that it's cheaper to make. And so I think it's great to have CNC as a tool to learn manufacturing better, learning what's the best tool to make it. You know, if you're making a flat plate, I had some around here, if you're making just a flat plate, maybe it's cheaper just to go out and, you know, use Send Cut Send or, you know, or not Oshpart, Big Blue Saw, you know, use any of those online water jet places or plasma, just have it plasma cut. So I think knowing, you know, what should be plasma cut, what should be water jet cut, what should be CNC'd, and sometimes you really just need to get the machine, get your hands on it, and figure out what it can and can't do. Because I see so many people doing two-dimensional thin stock parts on a CNC, and you know, honestly, you could probably outsource that and save yourself a lot of time and effort, and then use the machine for the more complex 3D geometries. So, yeah, it's I think knowing what it can and can't do is kind of that first step. And the good news is, like you said, there's so many really cool, accessible machines on the market, and I see them like I've been wanting to get a Avid for my company because it would be really nice to bring a lot of prototyping in-house. We're still going to have production done outside, but just having that quick, rapid prototyping being done. I think every company should have a 3D printer, a CNC machine, and maybe like a water jet or plasma. If you have all three of those, you've got pretty much your production prototyping covered.
A lot of good points there, and I agree with you. I think that knowing as first assessing what your goals are and where you are now, but then also kind of where you want to be in the near future. Because oftentimes I see folks start with a much smaller, more cost-effective machine, which I will highly encourage, of course, if that's what's accessible to you now. But if you are also planning on growing your business, maybe start with something you can expand or you can kind of grow into, or it can grow with you. Because a lot of times I see people outgrow their machine, something that has a fixed bed size, and then, they don't necessarily have, they have to just buy a new machine 2 years from there, and I also say definitely prototyping, if you're not, even if you're not going to be doing production in-house, which, you might not have the manpower or the hours to do it yourself, but the ability to prototype and understand manufacturing, design to manufacturing process, I think that's a big disconnect between people who are, machinists or technicians or fabricators, and then the designers. The designers don't, there's like that kind of communication issue where I think that designers should have, an intensive 1 week in the shop understanding fully the concepts of how folks approach manufacturing different kinds of parts. And this is something when I would teach CNC classes to kind of see the different types of people that would come, and some it's the chicken before the egg type of thing. They're taking the class to help inspire them to, they want to learn what CNC can do, and then that will trigger an idea, versus I have an idea, this tool will help me accomplish that specific idea. So it's kind of one, you're informed different ways depending where you're coming from.
Yep. And, it's all full circle, right? It comes down to what your goal is. What is the goal that you're trying to do? Like when we talked about, feeds and speeds and everything else. If your goal is to run 10,000 of something, do you really want to own the CNC and own that production, have the employee? And in a lot of cases, it totally makes sense. But if you're doing 20, you kind of have to weigh that concept of what is the cost of going out and just buying 20 of these units versus getting the machinery to do so. And I think that's what's so interesting. And that's what I like about what you guys are doing is you're actually making it complicated, because the machine now is cheap enough and the barrier to entry is small enough to where now the decision's a little bit harder.
Sure. Well, I think that's an interesting thing. Izzy's in the chat here. Izzy's just got his second machine in the shop. Congratulations, and thank you, Izzy, for all your support. And he's been kind of faced with this problem with like, okay, I've just designed this product, everyone wants it, I'm super, I'm like in this intensive production time. Either, I could outsource it, or I could get a second machine, because that machine will be completely paid for by this project. I could even have 3 to 4 machines running, 1 or 2 people to run them. You have 1 technician running 3 machines, and at the price point you can have 3 heads running versus 1 super high cost CNC machine. You can have 3 avids running, so sorry, Corey, I cut you off.
I was just going to say, as you talk about outsourcing, I feel like you're talking about community building, right? Because you're outsourcing to other these are makers that when you talk about sending it to a water jet or sending it to a machine shop, these people, they have a business of making. And I love that sense of community, in the sense that know your local machinist, know your local powder coater, know your local water jet company. If you're a maker, having those relationships allow for you to open doors for yourself, rather than just say, oh, I can't do that.
Oh yeah, great point. I remember the first day I had to get something water jet, because it was a combat robot thing, and it was S7 tool steel. It's just not something you want to machine. I had the capability to machine it, but it was just a dumb idea. It would be a lot easier to just use a water jet. So, I went in the phone book, talked around, found a water jet company, and they're actually still a sponsor of Copperhead today. And once I water jet the first piece, I've cut so many pieces with them, and I've used plasma now, and it just really opens it up, because I avoided using steel in a lot of components, because it's like, oh, I have the shop for aluminum. But then once I figured out that like, oh, you can just water jet cut, and it really starts making you think about new ways. And I'm a firm believer in making something in the most efficient way possible and kind of designing around that. So whenever I start a new design, I think about what's the best way to make this? Is it a 2D part? If it's 2D, maybe a plasma is the best way to go. If it's a 3D part, can I 3D print it, or can I do it machining? You know, it's like, it's fun designing, and the more tool knowledge you have, the more your design knowledge increases too, because you know how all these tools function. So yeah, it's really fun.
Awesome. Does anyone else have any last questions? If you do, throw them in the chat there. Well, this was super fun.
Yeah.
Corey, go ahead.
Well, I was going to say, yeah, no, I've really enjoyed this, and you know, I'm a serial learner or hobbyist, and you know, I could definitely see myself dipping my toe in some small combat robot areas, because having that feedback loop is something I really enjoy in machining, and then to leverage that into a hobby sounds like something I might dig into here as those meetups pick back up again.
It's the last thing I'll say about combat robots before I just beat this dead horse is the other fun thing is, you know, in my job, I do a lot of product development and things like that. And you don't always get to use a crazy cool material because, you know, you're building a bunch of things. And, you know, for something like this bot, you know, this is like, I think this is 5mm thick carbon fiber. I've got fiberglass reinforced nylon. I've got carbon fiber reinforced nylon, S7 tool steel. You just have all these fun materials that, you know, at the end of the day, there's actually a reason to use them. You know, I'm even using hybrid ceramic bearings. And when you're building one combat robot, you can do a $10 bearing, you know, because it's like, why not? Because you found out that the steel ones exploded on you. So, oh, let's try ceramic. It's a really good excuse to try out that stuff that isn't practical in standard product development. And in normal product development, you're always trying to cut costs. You're always trying to cut corners. This, you get to really push it to the limit, see what it can do. And then, you know, okay, I'll do tungsten. You know, oh, what about beryllium? You know, you look at all these crazy materials, and it's a good excuse to just try and use weird things.
Yeah, no, and to learn how to observe those weird or different new materials through different manufacturing processes, right? Like that observation. Yeah, I would not be surprised if you get a couple emails from me asking questions, or some comments in your videos asking questions as I dip my toe into this.
Oh yeah, of course.
I love coming up with project excuses to explore different materials and mediums, and just constantly trying to, you know, change and improve. And then next medium, that's what CNC has really done for me, is that I get to work in so many different processes and mediums. Yeah, love to explore. I don't like to be limited by medium, and that's something I think that you've really shown us. So awesome. Well, everyone, I guess you'll have to stay tuned for Battlebots coming up, and you can follow the Copperhead Facebook page, which I will add to the links in the description below, and be sure to go check out all the videos we talked about on Robert's page. Thank you so much for being here today with us. We really appreciate it.
All right, of course. Thanks for having me.
Thanks so much, Robert.
Awesome. Thank you. And tune in next week. We'll have Jonathan Katz-Moses on the live stream, and we'll see you then. Thanks, everyone. Bye.
Thanks. Bye.